All right. Okay. So today we work on this game. Okay. Um, we will learn a few things while trying to work on some version of this game. This is a pretty old game, so if you wanna see how it looks, you can, Google it. Okay. And the assignment for this week will be this game. I think you probably played it for once, right? Maybe. All right. So today we will basically try to rebuild the game framework, starting from the TK Inter code from previous lectures by Ajahn Chaiporn. Okay, we'll try to encapsulate all the dependency on TK Inter into some class, some modules, whatever. We'll do that because we will learn a few software design principles and some part of like OOP design, and then we also learn Git. Okay, so we will start by demonstrating on how to use Git when you work alone, and then we'll talk about how you would do that with the team, with some branching commands in Git, and we will look a little bit about on basic workflows, and we also talked about how to do some quick project planning using GitHub GitLab issues. Okay. All right, so let's get started. Okay, so if you look at this game, okay, basically you have a gorilla here. Okay, so we have monkeys. Okay, and then you have a banana. So a monkey can throw a banana to another monkey. Okay, so you can pick two things. One is the angle, and another is the starting speed of the banana. Okay, given that the banana would travel in the projectile directions, and then if it hits the other monkeys, then you're done basically. Okay, so that's the game. Okay. Okay, so I have the starting code here. Okay, basically I took this from Ajahn Chaiporn code. So we have a frame, TTK frame, and we initialize it so that it's gonna be a grid. So we're gonna have only one canvas. The whole thing will be just a single canvas, and that's it. And so this is the starting code that we will build on. Okay, so let's try to run it. Okay, so you see nothing, but it should looks like something is working. Okay, we'll work with GitHub. Okay, and I usually prefer GitLab, but you can work with GitHub. It's fine with me. Okay, so to get started, let's go to GitHub and create a new project. Monkeys demo. So let's have it this name. Okay, I'll make it public so that you can look at my code. Okay. Okay. So here's the repository that I have. Now let's try to push the whole thing to GitHub. Okay. You can create a repository here inside VS Code, but let's try to do it with command line first. Okay. I think you've been using Git before, right? So so I assume you know some basic commands. But anyway, so here's our directory. So to create a repository there, just call git init. Okay. So it says initialize git repository, and git keeps a snapshot of your work. Okay. It doesn't track anything, any file. It's just keep track of the snapshot. I mean, everything that you have at that moment. Okay. So to save that snapshot, you commit it. Okay. So basically, you might want to say git commit, and then it would keep the snapshot. But before you can keep the snapshot, you need to tell git to take that thing into the staging area. So staging area is like the place where you prepare something before you want to commit. Okay. So you basically you want to say you add so you can ls these are the three files. So I can say git add monkeys.py, or I can just say git add dot. It would take everything, but let's play something slower this time. Banana.png and monkey.png. Okay. And you can say git status to see the current status that we have for now. Okay. All right. Before we want to start further, okay. Normally by default, Git has the main in a repository you can have many branches. By default, Git has a branch called master that is like the main branch. Okay. But recently people hate the word master and slave because it's cultural and it's it's not good. So GitHub, okay, GitHub call it a main branch instead of a master branch. So we follow that too. Okay. So so we will use the main branch instead of master branch. Okay. We can just keep our version for now, and then when we push to the main branch at GitHub. Okay. So let's commit. You can either call commit /m with a message, or you can just call commit, and then Git will show you the give you an editor, a stupid one probably, so that you can edit. You can change the editor for sure, but let's try to look at it for now. Okay, you can say git commit with the message. Okay, so I can say empty windows, empty frame. That would be my commit message. Okay, if you don't do git commit -m, you can just call git commit, and then this will show you the stupid editor. So the commit message that you would like to put is something that when you look back, you should understand what you actually worked on, right? So currently we only show the empty frame, so we can say we show empty frame. That's it. Okay. You can say something like add something, whatever. But we'll stick with a simple sentence like this. Okay. We show empty frame. Okay. You can also say chose empty frames. That would mean the project chose empty frame. Okay. But if you do this, you mean you actually do the showing. You show the empty frame. Okay. So let's stick with this for now. And then we save it, and then it get committed. Okay, when you call git status again, then everything works. Now we want to push to this GitHub repo. Let's zoom in. You can do this. Okay, we want to push our existing repository from the command line. So just take this and then just push. Okay, so it push the main branch to the main branch at GitHub. Okay, and it also rename my master branch to main. Okay, so looks good now. Okay, so let's do some quick refresh here, so we can see that we have all the file here. All right. Okay, before we keep working on our stuff, let's do some quick planning. Okay, so if you look back in our game, we would try to build this game. So we want to throw a banana from this monkey to that monkey. Okay, it's good to try to work iteratively. Okay, for example, when you work with assignment from อาจารย์ Parut or อาจารย์ Pai อาจารย์ Chaiporn, you work in small steps. Okay, when you work on a project, you actually need to do that as well. You need to try to start with when you have a big project, you need to break down the work into smaller ones, and then keep working on when you work on smaller tasks, you can get it done much faster. Okay, and when you get some small things done, it gives you some quick reward. So that would that positive feedback loop will make you keep wanting to do more, right? So if you work on something too large, too big tasks, bigger than something that you can do in a few maybe hour or a few days, then you might stop working on it. Okay, so let's do some quick work here. In GitHub, you can do quick project management with GitHub project here. Okay, so if you go there, we can just create a project here. This is called a project board. A project board is something that you can track your work. You can add tasks. Okay, so let's look at here. You can have tasks and you can see the progress. So you can plan your project. You can have something like to do, in progress, and done. With this simple thing, you can actually manage a small project with just within GitHub itself. So let's do that. So monkey demo, just whatever name you like, create a project. Okay, and it doesn't have anything yet. So let's add a column. So basically you can have a column to do. So we stick with simple 3 columns. Okay, so we have to do, and then in progress, and then done. Okay, if you use Trello before, then it's simple as that. But if you haven't used it, the idea is that we'll look at the thing that we want to work on and break down into smaller tasks and put everything in this to-do list. Okay, this to-do list will be prioritized by the tasks that are the most important or the most appropriate thing that you should work on at that point. And then when you work on it, you can keep moving the card around. So let's do that. Let's try to do that. Like for example, let me show you some example. So here we have a monkey, right? So the first thing that we want to do is that we want to show the banana. Okay, so that's the first thing. So we will show the monkey later on, but let's make sure that we have a banana and the banana can fly and banana can move in a projectile. So that's the first thing that we would like to do. So let's say we start by show a banana. Okay, so that's the first task, and then the fly the banana horizontally. Okay, so just move on the x-axis. Okay, and then fly a banana, in a projectile fashion. Okay, so that's the three things that we will do. Okay, so we should order stuff, okay, based on the order that we would like to work on. Okay, so this is how we do a quick planning, and then when we start working on stuff, we can just move it to like say here in progress. If you work with your friend, you can see like who is working on what on this project board. Okay, so I'm gonna move it back. Okay, so we'll start with show banana. Okay, in GitHub. Okay, so this is just a card. Okay, and in GitHub you can link the card with the code that you're working on. Okay, by convert this to an issue. Okay, so you need to convert the card to an issue first, and then you can refer to it. Okay, because then you're gonna have a name. Okay, so let's say convert to issue, and then that's it, convert to issue. Then you have an issue number 1 here. Okay, you can always okay, so let's convert them all to issue. Okay, you can create an issue and then drag it to the project as well, but we start with the project, then we need to convert it to issues. Okay, and this issue will show up here. Okay, and you can set them the labels, like say make sure that it's a label on enhancement. Okay, you can do that. Okay, okay, they're all in enhancement, and the project would show that as well. Monkey demo. So this is the project board. Okay, so you can move stuff around. You might not want to put the tag here, but it will be good when you have enhancement and when you have bugs, and then they all have different labels, so we know what we are up to. Okay, all right, so we want to go ahead and build a show banana. Okay, so now let's go and work on our code. Okay, so we will do two things. Okay, we'll write some code and we'll fix it. Okay, and we'll try to get rid of all the TK inter stuff. Okay, so we're gonna end up with a game library or a game framework that when you write a game, you might see some small influence from TK, but we don't want to write our game in TK inter. Okay, because if you really hate it, you can just move to another framework without changing the core code of your game. Okay, so that's our goal. Okay, but for now, let's do something easy first. Okay, you want to show the banana image. Okay, so this is the banana. Okay, you want to show it. Okay, so you need to load the image. So you I'm gonna write the broken code first, and we see how to fix it. Okay, let's write the correct one first. Okay, so I need to read the image. Okay, so let's say banana image equal tk dot photo image file equal banana.png, and then from the canvas, let's create a photo. Okay, self.banana equals self.canvas create image. Okay, and then you need to specify the location, say 100, and then image equals self.banana image. And then that's it. Let's see if the thing shows up. Okay, so that's our banana. Okay, Okay, so but be careful, okay? Here, let me show you some crazy thing, okay? Let's say I have a local variable called banana image. I read a photo image and put it in this local variable, and then it should work. Everything should work, but then yeah, the image is gone. Okay, this is some stupid thing with Python binding of tk inter. When you do this, banana image is this is an object, okay? So it read a file and then it's inside this method create widget, okay? This method is called by a monkey game, and then after this method is called, Python see that this banana image variable is unused, so it would garbage collect this object, and then when the image when the TK would like to show an image, it's gone, so you're not gonna see it. So to prevent that, every image has to be kept out of the garbage collector. Okay, to do that is that you can just say self.banana.image, and then okay, when you do this, the image is kept within this object of class monkey game, so it's this app. Okay, so the image is not garbage collected, and then so you can see the banana. Okay, all right. Okay, so let's commit for now. Okay, it's small work. You can show the banana. We will commit it and then we clean up our code. Okay, so you can either clean up everything and then you can commit, but when we clean up stuff, we might break stuff, so let's commit it first. You can commit the thing inside VS Code here, add a file and then do the commit, but let's do it on the command line first, so that you get familiar with the command line. Okay, so let's say git status. You can see that there's this one file has been modified. Okay, so if you just call git commit, Git would say nothing to commit. Okay, you need to add the thing first. You need to add the file that the content, right, the snapshot, to git. Or you can say git commit /a. A means, like, you know, automatically taking everything that you modified that has already been tracked by git, so that's -a. Okay, so let me do the stupid way first. Okay, just add and then git commit. Okay, I'm not gonna put the message right away because I'm gonna show you one nice trick. Okay, so git commit, and then we say we show the banana, right? And but that's the sorry, that's the issue that we are working on, right? It's issue 1, so we can reference the issue 1 here. Let's say reference issue 1. Okay, so if you do that and then we push, okay, it push to the thing. If you look at this issue, okay, you can see that it should say something, right? Okay, in this issue you should see our commit somewhere. Okay, where is it? If you see the full detail, you can see that I've just added a commit. Okay, and this commit would appear inside this issue. Okay, so you can discuss with your friend inside that. Okay, okay, so, and you can see that this issue is still open. Okay, when we're done with this work, we can close this issue, so we know that we are done, right? Okay, but for now, we can link the commit to the issue. Okay, by just add the /sharp1. Okay, sharp1 mean this is issue number 1. Okay, all right, so let's do some cleanup. Okay, so the thing is that we're gonna have a banana, right? But we don't want to have you know, we don't want to say, okay, our banana should you should add this canvas, this banana thing. Yeah, so the way we do it is that we encapsulate the banana into something else. Okay, so let's say let's call a class. This is in game framework terms, this is called a sprite. A sprite is some image that you can move around inside a game. So let's create a class sprite. Okay, and in this class we would basically initialize the thing with let's do some initialize in it. So this sprite, it has to be able, you can either display a sprite, let the sprite display itself, or you either has something that take the sprite and show it to the canvas. Okay, this sprite eventually has to be on the canvas. Okay, okay, so we say we initialize the sprite with x and y. Let's do that, and image file name. Okay, image file name. Okay, that's how we try to initialize the slide. So let's say self x image file name. Okay, and then and here on the monkey game, so we would have self.create sprite. Okay, keep our sprite here. Okay, and then we will say define create sprite self. Okay, and then we're gonna say self.banana. That's the sprite, right? Equals sprite, and then give it the, we should have, I think I would love to have x file name before x and y. Okay, because it's okay not to have x and y even, right? So let's say default would be 0. If I don't put any x and y, the sprite will be at 0, 0. Okay, okay, so that's the sprite. And then let's say banana is going to be sprite, so let's call banana.png and then say 100. Okay, if everything, so let's comment this first. If everything works, okay, if everything works, if our sprite class actually works, then this should be enough. Okay, and then the sprite would show itself to the canvas or whatever, something like that. But you know, we not at that point for now, so it's a little bit too bad. Okay, so let's say we're gonna add the sprite should show up on the canvas. So when you create a sprite, we need to specify the canvas as well. Okay, so this is the thing that will stick with us for a while before we know how to get rid of the canvas. Okay, all right, so let's say so our sprite will depend on canvas for now. Okay, so we will clean that up later on. Okay, so you need to pass on the canvas to the sprite, so it's know that it's here. Canvas. Okay, and then self init. Okay, let's say that. Okay, and then in init canvas object, so we'll create the photo object there, over there. Okay, these two code will be there. Okay, so let's try to clean up this way. Okay, it's not the best thing that we can do. Okay, but for now let's make sure it works. Okay, init canvas object self, and then let's say self dot photo image file equals self dot file name, self dot image file name. Okay, and then self dot canvas object ID, right? So when you create something on a canvas, you have the canvas object ID. Okay, so then we say canvas dot create image. Okay, self dot x, and then self dot y, and then self image equals self dot image photo image. Okay. All right. So we have a class Sprite. Okay, and that class Sprite is here we create a sprite. Okay, and we need to pass the canvas to it for now. Okay, let's see if it works. Oh no, create sprite. Okay, colon. Okay, so we get back to the same code, but it looks a little bit better because here in our game we can just say we create a sprite and we just put the banana name and the original location. Okay, then later on we'll make sure the banana can move. Okay, but for now I think our code for showing banana should work. So let's commit the thing. So let's say git add, let me show you this, git commit -a. So it automatically take everything. Okay, and then it asks me to write a commit message. Okay, so extract sprite. The word extract is from the name of refactoring technique. The concept of refactoring, we will look at that later on. Okay, but this means like we take some class from we encapsulate something inside a class. Okay, and if we do this, and I think we're done with the this issue 1, so we can say resolve issue 1. Okay, if we put that, okay, GitHub will automatically close this issue for us. Okay, let's look at the board for now. Do some refresh. Doesn't say much, but the issue is should be closed. Come on. Oh, did I? Oh, I haven't pushed the thing. Okay. Okay. When I do commit, I just save it into my local Git repository. When you push it, it say close. Okay. So we're done with this. Here it say close, and we can just drag it to done here. Okay. Okay. So that's a quick, simple workflow for managing your work. And then we have this code. You can see that the number of open issue drops to 2. You can add README, but just ignore it for now. Okay. Okay. You can see that we just extract sprite cars and with the reference to issue number 1. Okay. Okay. All right. So now let's try to make the banana move. Okay. So we're gonna work on this. So drag this to in progress. Now we work on issue number 2. Okay. Now the idea is that the sprite class should to have a sprite, okay, so it should update itself. Okay, basically it should update itself. How can a sprite class update itself? So we should say update. Okay, so a sprite class should do something like this. Okay, and the monkey game should somehow repeatedly call update for the sprite class. Okay, so that you know it can you know move or whatever it would like, right? So that's the idea. Now how can we do that? Okay, okay, I ideally, okay, on this update for our banana we should say something self.x plus equal 1. Okay, we increment the x, but if we write our code here, say here, then all sprite will move to the right. Okay, not just the banana, right? So the way we gonna do is that so we just leave the past there. Okay, and then we're gonna have class banana here, that is a sprite. Okay, and then we just write define update self, and we say self.x plus equal 1. Okay, we would just basically ignore the init for now. Okay, because then we use the initialize for sprite here, and then here we're gonna change this to banana. Okay, now you can see if someone call update repeatedly, then you should see that the self.x change, but currently nothing works like that. But let's make sure that thing you can still run our code. Python monkeys. Okay, nothing happens, but this is something happened, right? We changed our code, but it still works. Okay, so now let's do the what is called the event loop of our game. Okay, from Ajahn Chaiporn lecture, you can see that we need somehow to call update. Okay, so to call update is that before we start the main loop, let's call this app.start. Okay, and in app.start we say app start self, right? So here we say self.after. So after some millisecond, you do something, right? So you say self.update. Okay, so this is the update for the monkey game. Okay, so let's say then we need to write define self update, and then here we just say self.banana.update. Okay, and then we say self.after self.update. So we make sure that it keeps running the update. Okay, 33 here is a magic number. We clean it up soon. Also this 100 is also a magic number. We clean it up soon as well. Okay, but now let's run, make sure that things still works. Nothing happened here. Why? Okay, no big deal, because nothing changed here, because banana.update just changed self.x, right? It doesn't move the actual banana. Okay, so our sprite class need to somehow make sure that it move, right? So let's create another function called render. So render shows the update thing. Okay, if you move, then it should move with you. Okay, So to move the thing, we say we use canvas.coord, right, coordinates. That's the code, right? I think here, right? Self.coordinates here, this method, right? We use this method, okay? But our canvas here coordinates, and then self.canvas object. So we want to change the location of this canvas object, right, with canvas.coordinates. Okay, so self.x, self.y, and then self.canvas object ID. I hope I have the right order. Okay, so after update, you need to render a thing. Okay, so you need to move things. So we say banana.update and then self.banana.render. So it's a little bit stupid that you need to call update and then call render, but we'll fix it later on. Okay. Oh, it doesn't move. So let's see if let's say print self.x. Let's make sure that x works. Okay, x change, but the banana doesn't work. So maybe have I call render. So let's print it here. I call render. So maybe canvas.coordinates is broken. So let me look at the code for a minute. Oh, okay. So I need the tag ID first. Why in the world I believe that I should have X and Y first? Okay, let's do that. Oh, okay. So our banana is moving. Okay, it's a little bit slow, but it's moving. Okay. Now, the update thing, I would like everything to be automatically rendered. Okay, so update here, after the update should call render here, and here is the update of monkey game, right? But it also renders stuff, so let's call it update and render. Okay, this is the bad name. Okay, in principle each method should do one thing and only one thing. Okay, but here let's keep it for now. Okay, because it updates and render. Okay, you can say animate like in Ajahn Chaiporn. Okay, so that would clean up, and it would but let's call it animate. Okay, so you might wonder why we have start and why we have animate. Yeah, I don't understand either. No, I'm kidding. So start is gonna be called just once. So after, let's say after 0, it's called animate, and then animate keeps doing that. Okay, after 33 milliseconds. Okay, let's make a constant here. Update. Okay, update delay, let's call it that way. Okay, later on on update we'll make it more fine grained, because we make sure that you get the real-time information on stuff, but for now we're happy with that. Let's let's try to move it a little bit faster. Oh, okay. All right, so are we happy with the banana moving on the horizontal line with the code this way? Probably. We need to clean up this banana thing for a little bit later on, because we don't want our game to we will take this out of monkey game, because many of the stuff here is like is common to all the games, and some of that depends on this particular monkey game. So we'll split it up, but we'll do that later on. Okay, so for now thing looks fine. Okay, so let's commit. Okay, git commit. Okay, so fly the banana horizontally, resolve issue 2. Okay, then I do git push. Okay, all right. Okay, and then we take it to done. In done, I'll put the latest one up front on the top. Okay, so now let's make sure the banana run in the projectile quickly. Okay, so you basically you need our banana is just, they're not gonna only have x and y, right? You need velocity. Okay, so you want to do a physics sim, right? So not just the x and y, you need velocity. So just x and y is not enough. Okay, so when you initialize the banana, you need to give it the velocity on the x and y, and then you need to have a g. Okay, so we have g gravity. So that's something that would pull, right? So let's say 5 unit. And then when you want to create a banana, so you need to give it the velocity. So let's say vx and vy. So vx would be 5 and vy would be like 20. Okay, like that. So for the banana, it's not enough to give just x and y. You should give it the velocity as well. So here init of a banana, it's a little bit more difficult. So it's it should be canvas image file name x and y, vx and vy. That's the thing. Okay, you can do that. Okay, and then you say super dot init canvas image file name x and y. You can do that, and then but things will get pretty crazy. Okay, right? Because when you do something, you need to go ahead and hack the constructor of a sprite, and then if you change the sprite, then you need to fix the banana stuff, and thing will get a little ugly. So we do something else. Okay, we're not gonna follow this path. Okay, so we're gonna keep the sprite interface untouched, but we will say self.banana.vx equals 5, self.banana.vy equals 20. So we do it this way. Okay, or we can either do this like self.banana.setSpeed. Okay, and then say 520. We can even do that. Okay, but we need to write some code first so that we can do this. We can either do that, we make sure that we can do both so that our banana class will look nice. Okay, but before we can do that, we need to make sure that we have initialize the Vx and Vy. So let's do this. Init Sprite self.vx equals 0. So let's make sure that we have some value for it. Okay, so banana has an init sprite, and here the nice thing about this is that let's say init sprite, we do this init sprite, we do this on a sprite, it would automatically call init sprite. So if you want to do something nice or some initialization without having to hack into the constructor of sprite, you can just write it in init sprite. So you can do some initialization here. Okay, so you make sure that the interface for the sprite, for creating sprite, remain untouched, and you can modify it. Okay, you can change it. Okay, here. Okay, all right. So and then you initialize it here, but now here we can assign the velocity at it. Okay, and let me create another method called set speed. Okay, Vx and Vy self, then self.vx Vx. So we can write it a little bit shorter, but then I'll set speed 5 and 20. Okay, now every time you update, you need to change the x and y. So let's say self.y subtract the Vx, Vy. Vy is like gonna go up, right? And then you say self to simulate a physics, right? So Vy minus equals gravity. Okay, so let's run it. Oh, too fast. Oh, the gravity is too much. Let's say 1 and Vy. So let's change it a little bit. So let's start at 200 and with speed 30. Let's run it again. Where is it? Oh, it moved too fast. 10, 20. Let's do it again. Oh, okay. It looks like it's working. Gravity is 1 is slow enough. Let me increase this to 300. What's the canvas height? So let's just change some option a little bit and then make sure it's travel faster. Let's run. Oh, okay. You can see that? Can you see that? Let's increase the speed. Oh, okay. That's my projectile, which looks fine. 25, 400. Okay, and 20. Okay, let's say. Okay, so that's the monkey thing. Okay, so that's the projectile. Let's see. Ah, okay, nice. Okay, so now things looks a little bit fine, and when we look at the physics thing, right, you can see that we can just focus on this banana class, right? Make sure that we get the physics right and initialization here, and then everything we just follows from our code. Okay, so let's commit it for now, and then we will clean up this stuff. Okay, we work on this monkey game class. All right, git add monkeys. git commit. Let me okay, so move the banana in a projectile fashion. So refer to issue number 3. Okay, save, git push. But we're not done. Okay, I'll clean up this thing a little bit. So, but you can see that this should give you the where is it? So the main issue here, you can see that this commit is linked with this issue. You can just look at the code, the stuff that we changed. Okay. All right. So let's clean up this monkey game. Okay. So the monkey game, we would like to encapsulate the TTK frame inside our work. So there are 2 ways to do that. We can do it by using inheritance. So we would create a base class inherited from the ttk.frame, and then our monkey game would inherit that other class. Okay, like basically game base or something, and then work on that. We can do that. Let's try to do that first, and then we'll see some restriction with that, and then we'll do something else. We'll encapsulate it by create another class on top of it that contains a frame. This is called composition. Okay, so there are two ways to extend functionality. You can inherit, you can do inheritance, and you can also do composition. But composition is usually is easier to work with. Hence people usually say composition over inheritance. So this is what we will see soon. Okay, so let's create the class game app. Let's say call that. So I'm gonna basically extract my monkey game class out of this. Okay, so I'm gonna take my monkey game here, and I just rename this to be the game app, and I'll throw away everything related to monkey game from it. The canvas is there. Create sprite. I would just say I will take it out right now. Okay, when an animate need to do some things here, then I'm dead, right? So basically what I would do is that I would call self.init game. Okay, and then I have a class called init game here. Again, do nothing, and then animate. I will put, okay, I'll keep all sprites in a list. Okay, so let's call I won't have any create sprite. I have init games, and then I say self.sprite. Okay, be a list. Okay, and then I call init game. Okay, now what I would do is that I would for sprite in self.sprite, and then call sprite.update, and then sprite.render. Okay, I then init game would just be this create sprite, and then init game, I would just self.create sprite, and then self.sprite.append self.banana. Okay, So now I have all the sprite. Oh, what is wrong with that? Why do I have this bad lines? Okay, so here in my game app, I would basically create widgets. That's the canvas, right? So let's rename it, create canvas. Okay, I can create canvas because I have no widget, right? I only have a canvas, and then I have a sprite, empty sprite list, and then in init game I would expect someone to work on that. Okay, game app. Okay, so let's run. Okay, everything works. Now you can see that if I just take this banana out, game app and monkey game, I only need this banana and monkey game app, right? The other thing would be this other thing is just a game library, right? That basically these are the TK inter stuff, right? That I have extract out. Okay, so we can just move everything here to another file. Okay, but then there's a canvas width and height here that I'm a little bit uneasy about. Okay, because in create canvas I need this big constant, but we'll do that later. Okay, so let's commit for now. Let's see what we have changed. So we extract the game app and move stuff around. So okay, extract game app, and then we can say we resolve issue number 3 and push. All right, so here at our board is closed, so move it to done. I don't need it anymore. How can I close this thing? Okay, so we're done with all the to-do list for now. All right, so and our game is simple enough that you can see the projectile. All right, so so this first clip, let's stop at here, and then in the next clip we'll clean up a little bit more, and then we'll show you how you work with your friend. So we're gonna make sure that we have a game. So one of you will work on adjusting the angle of the banana. Another will make sure that you show 2 monkeys, and then you check if the banana hit another monkey. Okay, to do that we'll learn about Git branch and how to work with a team inside Git. Okay, and also we clean up our game code a little bit more. All right, so that's it for this clip. See you in the next clip. You can just watch it right away after this. Okay, see you.